In the first record of this section of chapter 4, I gave the strategy to curve sketching. In this strategy, we should calculate the asymptotes. And you know how you can calculate the vertical and the horizontal asymptotes. But sometimes we need the oblique asymptote. What is the oblique asymptote? The oblique asymptote is a line, but not horizontal or vertical. And the function approach to that line when x approaches infinity or minus infinity. So this is called the oblique asymptote. So the definition of the oblique asymptote is if a graph approach a line, okay, let's write. If a graph approaches a line that is neither horizontal nor vertical, as x approaches infinity or minus infinity, then that line is called an oblique asymptote. Some books says slant asymptote. So, geometric interpretation of this fact is we have a line, not vertical and horizontal line. For example, this line. The graph of the function approach to this line, okay, like this one or like this one. So, if the equation of the line is mx plus b, this general form of the lines, okay, so limit when x approach plus infinity or when x approach minus infinity, the differences between the function value, what is the differences? Let's show that. This is the differences. This is differences. This is differences. This is differences. So differences approach to 0. Okay. So mx plus b goes to 0. In this case, y equals mx plus b is a oblique asymptote. How we can find the oblique asymptote? For the polynomial type function, by dividing your polynomial to the denominator, or actually by dividing the numerator by the denominator, you can calculate, okay? So if f of x is the form n of x over d of x, okay, rational function, here degree of n of x is 1 more to the degree of d of x plus 1, okay, then we can use the polynomial division to write the you can write the f of x in the form m of x plus b plus remainder of x over d of x. How we can write? By using polynomial division. So n of x over d of x, okay, here the degree of the r is the less than the degree of the d of x, and the mx plus b is the result. So this is mx plus b, and this is the remainder rx, okay. So degree of rx less than degree of d of x always. So this part, when x goes to infinity, approach to 0 when x goes to infinity or minus infinity. So mx plus so f of x minus rx or dx, so f of x minus mx plus b goes to 0 because of this reason. From here, since usually you can obtain f of x minus mx plus b equals rx over dx. So right hand side goes to 0 when x goes to infinity or minus infinity. So mx plus b is the oblique asymptote for the polynomial, rational polynomial function.